Hey guys, we're gonna start soon. Just getting myself ready. Cool. Uh, this is test 1C, and I'm gonna be using approximation. So it's similar to test 1B and A. Just slightly different. So what we're getting from the text file for the task is the value that we're approximating, which is less than 1. And we need to do at least a sum of 10 values or more. Okay, so we're getting in a double called x from our text file. I'm just declaring and initializing it. Since we have multiple values in the input file, we are going to use a while loop. I'm going to read in to x. Right. So for each value that brings for each value of x that we get, we're going to run a for loop that starts, it's called let's see, yeah, let's initialize it to n, which starts at 0. If you look at your summation, you see that for arctan x it goes from 0 to infinity, but we are doing the first 10, so we're going from 0 to 10 in steps of 1. Okay, and for each time we do it, what do we have to do? We have a formula there, right? We're going to put in that form, so we're going to perform that formula, right? So I'm going to make another variable to store the sum that I'm going to output, and remember I need to continuously add that sum with the previous sum that I'm getting. So it's like the first term needs to be added to the second term, to the third term, and so on. And I'm going to use CMath. So first term is minus 1 to the power n times x right, to the power, I'm going to use brackets because there's an operation performing, 2 times n plus 1. And then we are dividing this entire thing. I forgot to put a comma. Dividing the whole thing by 2 times n plus 1. Cool. And then you want to see out. I'm just doing this to check if I'm getting the correct answer. And remember that after you've done a summation for the first number in your file, you need to reset that summation so that when you do the next value, it starts afresh. It doesn't include the summation of the previous x value. Cool. Right, I'm not getting the correct output. Oh, I forgot to. I need to fix my input file. I forgot to do that. So let me just do that quickly. It needs to have 0.5, 0.9, negative 0.9. Save that. Get back to my code. Cool. Let's run that again, see what we get. Right. Can you see that we're slightly off with our approximation? Okay. So what I'm going to do is not make it 10 but 15 and see if we get a closer answer. 46473. Okay, it's a bit too much. Let's go with 30. 7.3. This one's okay, but this one's a bit off. Let's make it 11. Okay. Oh, it's 15 again. 7.32, which has got 3.
When you're using a car?
No, did it?
Okay, I'll see you later. No?
Okay. Okay, so slightly bit off for the first one. Alright, so I'm gonna stick with 17, and what I'm gonna use is to fix to 3 decimal places. I'm gonna include IO manipulation, and this will help me set precision to 3 decimal places. But remember, you need to use fixed because if you don't, it's going to start fixing the precision from the front of the number. Fixed allows it to start counting decimal points after the decimal point. Start counting numbers after the decimal point. I'm gonna run this again. We should get the exact, yes. Okay, cool. Now let's try example 2. I just want to see if you're getting the same values as the, how do I, so I'm quickly just going to my input file and inserting all the example values: 0.1, 0.2, negative 0.3, 0.4. During your test, please test both the examples they give you. 0.2. 9. How many nines are there? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Yeah, 6. 1, 2, 3, 4, 5, 6. And then the last one is negative 0.0. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Let's save that. Go back to my code quickly. Right, there we go. I'm gonna run the code, see if we get the same output into 0.2. Oh, 0.1. Yes. Okay, so we are getting all the correct outputs. I'm going to take this to my output file. Remember, you need to open one. Name it output.txt. Cool. Okay, guys, thank you.